the next point. We should ensure whatever we see is clear.
That means work is being done. We can see that it is in opposite direction. Good day, learners at home. Welcome to today's physics lesson on radio and television e-learning program of Kaduna State Ministry of Education. My name is Hassan Buki. Today we shall be considering the topic conduction of electricity through liquids, and we shall be looking at part 1. We have the outline as follows. Definition of terms, then we will look at the electrolysis of acidulated water. We say this aspect of physics deals with the study of the flow of electricity in liquids. Some liquids conduct, or we say they allow electricity to pass through them. And we call this type of liquids electrolytes. Examples are bases and acids. That means all bases and all acids conduct or allow electricity to pass through them, and we call them electrolytes. While others do not. That means there are some liquids that do not allow electricity to pass through them. That means they do not conduct electricity, and we call them non-electrolytes. An example is distilled water. A distilled water is a non-electrolyte. Why? Because it has been deionized. All the ions that it contains have been neutralized and formed a neutral atom or molecules. And that is why it cannot conduct electricity. The mechanisms of electrolysis shall be illustrated using the electrolysis of acidulated water and copper sulfate solution. So we shall be looking at these two. Now, first we will look at definition of some terms. 1. Electrolysis. Electrolysis is the process of decomposing liquids and solutions into their component parts by passing electricity through them. The next one, 2, is electrolytes. And we say an electrolyte is a liquid which will conduct electricity and can be decomposed into its parts in the process. That means it can conduct electricity and it can be broken down into its various component parts in that process. Examples are organic acids, bases, and salts dissolved in water, and fused organic compounds. Number 3, electrodes. Electrodes are solid conductors in contact with the electrolytes, through which current enters or leaves the electrolytes. Now, the difference between the electrolytes and electrodes is that electrolytes, they are in liquid form. Electrodes, they are in solid form. All of them are conductors, but electrolytes are in liquid forms, while electrodes are in solid forms. 4, ions. Ions are charged particles which exist in electrolytes and take part in electrolysis. They are charged particles. That means they are either positively charged or negatively charged. 5, voltameter. A voltameter is the vessel or container containing the electrolytes and the electrodes. So the vessel or the container that contains both the electrolytes and the electrodes is called a voltameter. Now here we have, this is our voltameter. This is the container. Here we have the electrolytes. Then we have our electrodes. The cathode, which is the negative pole, and the anode, which is the positive pole. Electrolysis of acidulated water, that is water that acid has been added into it. The Hofmann's voltameter is used in the electrolysis of acidulated water, and it consists of two graduated tubes, a water reservoir, and two platinum electrodes that are connected to a battery. Few drops of sulfuric acid are added to the water to increase its conductivity. Now here we have the Hofmann's voltameter. This is the setup for the electrolysis of an acidulated water. Here we have the two tubes. This is our water reservoir, okay? Here we have our platinum cathode, which forms the negative pole. Here we have our platinum anode, which is our positive pole. Here, above the liquid in this tube, this place here, what is contained there is oxygen. Here we have hydrogen. In this empty space is hydrogen gas. Then we have the connections made, okay, to a battery or a source of electricity. Now, when current is passed through the water, oxygen and hydrogen gases form at the anode and cathode respectively. And the volume of hydrogen produced is twice that of oxygen, just like we have seen in the diagram. So when current is being passed, what happens is oxygen is formed, okay? We have for oxygen formed at the anode, then at the cathode, we have hydrogen gas. At the anode, we have oxygen gas. Now the water dissociates into hydrogen and hydroxyl ions, while the sulfuric acid dissociates into hydrogen and sulfate ions. So here we have water dissociating to form hydrogen ions and hydroxyl ions. The hydrogen ions are positive ions. The hydroxyl ions are negative ions. Then the sulfuric acid, H2SO4, dissociates to form hydrogen ions as well as sulfate ions. Hydrogen ions, which are positively charged, then our sulfate ions are negatively charged ions. As current passes, hydrogen ions move towards the cathode, where they gain electrons to become neutral atoms, which then combine in pairs to form hydrogen molecules. So here we have the hydrogen ion. As it moves to the cathode, it gains an electron and forms a neutral atom, which now combine with another neutral atom that has been formed to form hydrogen molecules, H2. At the same time, the hydroxyl and the sulfate ions, which are negative ions, okay, they move towards the anode, that's the positive pole. And at that point, the hydroxyl ions only lose their electrons as a result, okay? While oxygen is being liberated. Oxygen is being liberated, while the sulfate ions, they lose their electrons at that point. Now, the sulfate ions remain in the solution. So we have hydroxyl ion losing an electron to form a neutral molecule, OH, hydroxyl atom. Now, two hydroxyl atoms combine to give us H2O, water plus oxygen. Two oxygen atoms again combine to give us oxygen O2, which is oxygen molecule. Now we look at electrolysis of copper sulfate solution using copper electrodes. So we have the diagram, we have our voltameter, we have our electrolytes, which is copper sulfate solution. We have our two electrodes, the copper cathode, which forms the negative pole. We have copper anode, which is our positive pole. Connected, they are connected with a key and to a battery. Here we have an ammeter to read the amount of current passing through. Now, the passage of electric current through the electrolyte for a period of time results in copper being deposited at the cathode. So at the cathode, we have copper being deposited. At the anode also is also observed to have lost an equal amount of copper. Now, as copper is being deposited at the cathode, okay, at the anode, it is observed that copper is being lost. And the amount that is being lost is equal to the amount that is being deposited at the cathode. The passage of electricity does not affect the density of the copper. Copper sulfate, CuSO4 solution contains copper ions, Cu2+, sulfate ions, SO4 2-, as well as hydrogen ions, H+, and hydroxyl ions, OH- from the water. So the copper sulfate solution contains all these ions. So during the passage of electricity, both copper and hydrogen ions move towards the cathode. However, only copper ions are discharged or deposited at the cathode, while hydrogen ions, they remain in the electrolyte. The hydroxyl and the sulfate ions, which are negative ions, they move towards the anode. That means they move towards the positive pole. The copper atoms of the anode go into solution as copper ions, where they combine with the sulfate ions to form copper sulfate. So the concentration of the copper sulfate remains the same due to the fact that copper is going into solution from the copper anode at the same rate as copper is being discharged at the cathode from the solution. So the anode therefore dissolves and is deposited at the cathode. So during the process, what happens is the anode is being dissolved and is being deposited at the anode. So we will see that as the process is going on, the anode will be decreasing in thickness while the cathode will be increasing because it is being decreased here and then it is being added on the other side. So we have copper sulfate CuSO4 dissociating to form copper 2 plus and SO4 2 minus. That means copper ions and sulfate ions. Now, what happens at the anode? At the anode, copper ions gains electron and it becomes copper atom, neutral atom. Then at the anode, okay, at the anode, copper loses electrons to form copper ions. Now, these copper ions now combine with copper sulfate to form copper sulfate solution. As the current continues to flow through the electrolyte, the anode continues to decrease in thickness while the cathode continues to increase in thickness, because I've said already before now that as the process continues, the anode decreases and therefore it will reduce in thickness. As it is decreasing, it is being formed it is being collected at the cathode, so the thickness of the cathode increases. Learners, with this one, we have come to the end of our lesson for today. But before I go, I will call on my colleague, Mr. Napoleon Kure. He will come and summarize and then give you assignment to do while you remain at home. Once again, I remain Hassan Buki. Meet you again in our next lesson. Have a nice day. Thank you.
Hello, learners. You've just listened to my colleague, Buki Hassan, on Conduction of Electricity Through Liquids, Part 1. And you should know that electricity does not only pass through liquid, it passes through solid, through liquids, as well as through gas. But in particular, we are looking at what happens when it passes through liquid. And there are some terms you ought to familiarize yourself with to help you know what the concept of electrolysis or passage of current through liquids. Some of such terms are as follows. One, talk of electrolysis, which is a stem or the main word there. It simply refers to the process of decomposing liquids and solutions into their component parts by passing electricity through them. As you can hear, the word decompose simply refers to breakdown. As you know that molecules are on one hand, atoms are another, then we have other forms of particles known as ions. The ions could be positive or negative. And the breaking of atoms into ions, positive or negative charges, are what we refer to as decomposition. And in that case, the positive ions are called cations. Negative ions are called anions. Well, the electrode that are made up of positive or are referred to as positive electrode, they refer to them as the other way around. Cations, positive charge ions, while the cathode is a negative charge pole. And then the anode is like the opposite of what that one is all about. Cations, positive charge ion, anions, negative charge ions, where cathode are positive and negative charge ion, and then anode are positive charge electrode. We say, and so electrolytes, what are electrolytes? Electrolytes, on the other hand, is that liquid or the solution through which current pass through. And then when it happens, such breaks into the various components. And as we said, such are inorganic acids. For instance, an example of electrolytes, bases and salts that dissolve in water. and then fuse organic compounds. Now, for the electrodes, as I said, they are solid conductors. As my colleague told you that electrodes are solid, while electrolytes are liquid. There are also substances that allow the passage of current, but this time around they are in solid form. And as I said, the current passes through them, and as they are inserted inside the electrolytes, current enters the electrolyte through one of them and then leaves the electrolyte to the other. As we've said, ions are just charged particles which exist in electrolytes. The decomposition or dissociation is what happened. The discharge or the breakage of an atom into different ions is what we refer to as that. So when ions are formed in a liquid, then we say decomposition or breakage, or we say dissociation of atom has taken place. Voltameter, on the other hand, is a container or just a device that contains electrolyte and the electrodes. And the diagram has been shown. There we have anodes through which current enters the voltameter or the electrolyte. Well, the cathode is the solid or the substance through which it leaves the electrolyte. That's a diagram on that. Then on the electrolysis of acidic water, we have this instrument, and a bit complicated compared to our voltameter, known as Hoffman voltameter. It contains, as my colleague has said, a tube glass with a reservoir. The tube glass are on both sides. One has the cathode and the other one anode. Well, you have a container that is a reservoir that has the water in it. And inside the reservoir, these cathodes and anodes are inserted, where you have, just as you know what we refer to as Coulomb's law, that says positive charge repel, when positive and negative are joined, they attract each other. Then the other ones repel. So we see that the ions that are positively charged will go to those ones solid, or we say electrode, that are negatively charged. While the ones that are negatively charged will go to the ones that are positively charged. And the chemical equation has been shown on how this happened, which my colleague has explained to you. With this, we want to, give you an assignment to keep you busy and make reference to what we have just said this morning, so as to help you. This assignment is not limited to what we are going to give you. Please, you contact other books with references also are going to give to help you search more information on the same. The number one assignment is explain the following terms. A, electrolysis. B, electrolytes. C, electrodes. D, voltameter. Number 2, explain what happens at the cathode and the anode in the electrolysis of copper sulfate solution using copper electrodes. I take the assignment again. Number 1, explain the following terms. A, electrolysis. B, electrolytes. C, electrodes. D, voltameter. Number 2, explain what happens at the cathode and the anode in the electrolysis of copper sulfate solution using copper electrodes. With these, references are as follows. 1, New School Physics by M.W. Anyakoha. 2, All-Inclusive Calculations in Physics by Solomon Dauda Yako. And then 3, Senior Secondary School Physics by Piano Keke and M.W. Anyakoha. With this, I want to suggest that please don't assume that all is over until it is all over. Make sure you go over this assignment over and over and contact more work, as I said before now, that it will go to help you to prepare you. There are a lot of questions, past questions, WAEC, NECO, and JAM, that you can go through to prepare you. And our contacts on any problem you have, or maybe you solve the assignment you want to get across to us, as follows. Hassan Buki, 08065504346. I take it again. Hassan Buki, 08065504346. And Napoleon Kure, 080-3636-2105. Napoleon Kure, 080-3636-2105. You are advised to keep on staying at home as you stay safe and keep learning. We meet in our next lesson. Once again, I remain Napoleon Kure. Thank you.